Hi everyone, welcome along to lecture 18 of the Alphacam side of our Advanced Manufacturing Technology module. And today we're going to talk about a few things, but the main focus of the lesson will be the use of existing Alphacam tooling as well as the creation of our own custom tooling. So back over to Alphacam. Just before we begin talking about the tooling, I want to cover a few small bits that I may not have covered to date. So I'm just going to go to geometry and draw a rectangle of any size. Let's start it at 0, 0 and maybe an A4 sheet. So 210 tab 297 enter, and let's just give that a bit of depth. So 3D set materials, click the edge, and let's go 0 then minus 20, just so we have something there to work with. This only came online a few years ago and I'm not quite used to it myself, so I probably should be encouraging you more to use it more. But if you right click anywhere, you get this quick, I suppose, a shortcut command toolbar. So explore that for a couple of seconds there. For instance, if you right click it, you can press these little black arrows. They always expand the menu out more. So here you can get the move and the copy and the rotate. This black arrow gives you a lot of the sketch tools like fillet and extend and offset. This is the one I want to talk about because this came up during the week. Someone asked me how to change the background color. So the handiest way, without going into the tools and deep into the menu, just right click anywhere on the screen and hit this icon, background color. And that allows you to change whether you have a gradient. You can see by default we've got a gradient from blue gradiating down to grey. So you can change the two colours. So you can go from, say, a yellow down to grey. I'll cancel that. Or you can just go a solid fill. So a solid fill colour, you can pick any colour you like there. Now just on a side note, I'm going to cancel all of that. On a side note, if you happen to be recording videos ever like I am here, it actually takes a lot more computing power and memory to record a video with a gradient background like this as opposed to a solid color. Now I haven't changed that because it's not really making my file sizes that much bigger, but if you're ever recording CAD or recording software like this and you find the video that you create is nearly a gigabyte in size afterwards, just try making the background color like this, making it a solid color rather than a gradient. Okay. So while we're at it, I just want to show you one other thing. We're going to talk today about the creation of tooling and the use of tooling. We're also going to apply some tooling and apply some tool paths. But there's one type of tool path we haven't discussed yet. So if I get up here to machine, I can see there's a manual tool path that I can select. So I want to do that in a second, but the first thing I have to do is go select tool. You can see that's grayed out in the same way that all the other machining operations are grayed out. So let's go to select tool and let's just pick, I don't know, the engraver, user engraver, 30 degrees. That'll work. And as soon as I select that, you'll see manual toolpath is visible and clickable and selectable, but all the others aren't. The reason the others aren't is that there's no geometry down here. If I was to just put a line, let's say that line there, now if I go to machine, all the others are possible to select because they all now can be applied to that geometry. But if I press undo, you can see a manual toolpath is a type of machining operation that does not actually require any geometry. So let's press it. Manual toolpath. And the general is just going to allow me to change the cutter. I'm happy enough with the cutter. The user engraver, I just selected that. Levels and cuts, I can change those and set those as I've always set them. So let's just set those, let's say to -3 there. Machining data is the same. I'm going to leave that alone. Tool data, I've kind of ignored this up until today, but it's going to be important today. This tool data, the reason I'm going to ignore it is whenever this tool was created by whoever created it, all of this speeds and the cut feeds and the spindle speed and the diameter of the tool and the tool number, all those things would have been populated. And every time we then pick up this tool and use it, it automatically pulls in all that data for us. So we usually don't have to worry about that unless we're actually creating our own tool, which we'll do shortly. So I'll just press OK. And now what I can actually do is just click various points like this. And as I do it, not only is it drawing on the geometry, but it's also drawn on a toolpath. So if I press OK, and then we go to View, Solid Simulation, and Play, you can see it's going to pull that cutter in the direction and along the lines I've just drawn a minute ago. So I'm going to press undo to get rid of all that, and let's do it a little bit more precisely. First of all, I'll turn off the solid simulation, and I pressed undo too many times, so I'll go to 3D, set materials, and I'll bring back my block. And this time I'm going to go to geometry, but I'm going to turn on construction and I'm going to go to special geometries, and I want to pull up a, not that, but a polygon. And the polygon is going to be a hexagon, or even a pentagon. Let's print 5 sides, and the diameter of the describing circle, let's make it 150. Let's press redraw so we can see a preview of it, and press OK. And I'm just going to put it on by eye somewhere in the center, and because it's a construction, now if I go to machine, you can see the same thing applies. The only thing that's possible for me to click is this manual toolpath. So I'll press manual toolpath. Before I do that, actually, I'll go to view XY, just so I can look straight down on top of it. Then machine manual toolpath. And I'm happy enough with everything except for that -3. I'm going to make that a little bit deeper this time. So let's go -5 and press OK. And the snaps can be turned on, which will allow me to go all the way along the outside like this. Let's actually go from corner to corner like this. And you can see I'm using the construction just to lay down the kind of shape of it, and then I can trace over it click by putting on the geometry as well as the machining operation in one go. So let's now go to ISO, and when I'm happy with that, I'm going to press escape a couple of times. And then if I do the solid simulation, we should get everything applied in one go, which we do. So I know a lot of people that use that because if it's simplistic geometry, why waste time actually drawing on the geometry and then afterwards going and applying the machining operation when you can do it all in one go. So let's take a look now at the tooling that is already there by default in Alphacam when you open it up. So our exposure to that so far has been when we went to Machine, Select Tool, this window shows us all the tooling that's available. And there's actually a couple of different folders that we've not gone into previously. We haven't gone into the inch folder. You can see there's a lot of different tools there. For example, there are all the imperial inch twist drills. Let's close up that folder. And you've got metric, 2 folders, calculated speeds and fixed speeds. And it's essentially the same thing. It's just how fast the cutters are going to go. Is either calculated automatically in these metric ones or fixed. That means we have calculated it and we've set those tools to be very specific tooling. So let's just go with the fixed speeds for now. If you expand that down, you can see all the different toolings there are laid out into all the different folders. If you pick any one, let's just go into the metric fixed speeds. Let's go to say, the bull nose and just pick anyone at random there. Now you may have a different set of tooling. It doesn't matter. Just pick a tool and you can see whenever you select the tool, you get a graphic down the bottom left hand corner, and you also have a lot of different properties over on the right hand side here for each of the tools. For example, there's the fixed speed. Here you can see the radius, you got the diameter, the type of cutter it is. If I go back and just click the metric folder itself, or back up here actually to the main folder, to get back to the default folder, you just press this top button up there. Let's go to the flat 10mm cutter, which is one that we've used an awful lot. You can see there's the preview. You can see in this case it's tool number 3. It's a flat cutter. It's got diameter 10mm, and all the properties belonging to that tool are listed. Now in some instances, such as the example we were working on previously, you may have to use a tool with a very specific cross-section that is not in the library. So if you remember this example from a couple of weeks ago, we did the pocketing exercise, we did the spline, and we sent the 10mm groove, or the flat cutter I should say, along the groove. But we didn't actually have a tool with this profile that you can see in the top right hand corner of the screen to process the edge profile. So we had to create our own profile, and we didn't do that. So let's just have a look at the process involved in creating our own tools. So back in a new Alphacam file, I'm going to go to View and XY, and just to have something to draw, let's draw the same sized rectangle as that phone stand required. So the first point is going to be at 0 tab 0 enter. And the other point then is going to be at 220 tab 145 enter. There we have it. So we might as well go 3D set materials, and we click the edge and set that to -20 is fine. And now we have a block to work with. So if I want to create a new tool, you simply go to machine and then over here define tool. When you define tool, there's actually 2 different types of tools. Well, there's a number of different, but there's 2 categories usually. There's user defined, and then there's these kind of default sets. The flat end, for example, the bull nose, the ball end, all of those are kind of set pieces. So the bullnose is always going to be a tool that will more or less make a straight slot, a trench but with rounded corners. The flat end will just make a perfectly square or rectangular trench. But the user defined requires an extra step. You actually have to draw the profile of the tool. So we'll get to that in a second. Let's start with the flat end. So when you select define tool, you are then prompted to select the type you want, so flat end. And you can see here, this is tool number whatever. It depends on your workplace. If there's already a tool number 1 or a tool number 2, then you probably don't want them to clash. So let's just call this tool number 101. The length of this will be 100, let's just say. And if it's going to be a 12mm cutter, we can then press redraw and it'll give us a preview of the tool. Special, there's no actual special in this case. I could put a taper on it. Let's say I put a taper angle of 12 degrees and press redraw. Now you've got that engraven shape at the bottom. But I don't want it to be tapered in this case, so I'll select none. CW and counterclockwise, I forgot this actually, metric and inch, that's self-explanatory. CW and CCW is either going to rotate clockwise or counterclockwise. Cut depth, depth of cut and the maximum depth. The depth of cut would be something like 10mm. The maximum depth might be, say, 10mm or 12mm as well. And if you press redraw, you can see the maximum depth as I change it and press redraw. It'll actually specify the little safety cutoff. So that tool now should only allow you to cut in depths of 15mm at a time. So if you have a very slender diameter cutter, like a 3 or a 4mm diameter cutter, you certainly don't want to be cutting 20mm at a time. So you can set in a little safety there if you want. Now I'm actually going to leave both of those blank. Press redraw. By putting a 0 in there, it simply means that you haven't specified it. The depth of cut, really, if I go to 30, that means that of this piece of metal, the top, or sorry, rather the bottom 30mm is the bit that will do the cutting. There's no blades or no sharpness above 30mm on that. But I'm not going to specify that for now. Here you've got speeds. They can be calculated or fixed. Calculated means it's going to automatically determine it, the speeds and the feed rates for itself, but more than likely you'll select fixed, which will allow you to specify your own unique spindle speed, your own fixed feed, and your own fixed down feed. The spindle speed is the speed that the cutter will rotate at. The fixed feed is the speed at which it will move across the timber, and the down feed is the speed at which it will, in the Z direction, plunge down into the timber. So if I just press OK on that, you can see I haven't given it speeds. It needs fixed speed, so I need to put in there 18,000 RPMs or something like that. So for now, for this instance, I'm just going to go to calculated. I'm going to show you in a few minutes how to determine the best spindle and fixed and feeds there. So I'm going to go to calculated, and that means it's going to calculate whatever it feels is the best, and press OK. Now it tries to create the tool. And try to remember this path. You can see I'm in a folder called routertools.alphacam. And Lycom data, Alphacam, local disk C, this PC. And it's important to know that because all of the tools on my computer live in this folder. And you can see the folder we were looking at a minute ago, metric fixed speeds, metric calculated speeds. We accessed those a few minutes ago when we went to select tool. They're all in here. So I'm going to call this Des's sample tool. Spell it right. And I'm going to press save. And it says Des's sample tool has been saved, so press OK. And I don't want to create another tool, so I'll close that. I'll go to View and ISO. I'm going to go to Geometry and just draw a line across like that for now. Now that I have that geometry, I can go to Machine, Select Tool, and in there you can see Des sample tool. And it's tool number 101, it's a flat tool, it's diameter 12, and all the settings are there. It's length 100 and so on. So if I just double click that, it comes in as the default tool. I can then go to rough or finish. Let's just set some, that's fine, that looks good to me. Select the green line and press finish. And now I know it's not that complicated looking, it almost doesn't look like I've applied a new tool, but that is the new tool I'm after creating. So how people use that is if they buy a new cutter that is not in the existing library, or if they send their cutter off to be sharpened and it gets a little bit smaller, then they can get back in and edit the tool or create a new tool so that digitally it's going to represent what will happen physically more accurately. So I'm going to stop that. Let's go back now to Machine, Define Tool, Go back into flat end, you can see all the settings are there, they're blank again. If I cancel that, I can go to bullnose. This is very similar in that I can give this a tool number 102. I can tell it to be a length of 100. That means the piece of metal itself is 100. Diameter this time, let's make it 12.5. The corner radius now might be 2 mil. And press redraw, and you can see that's the difference between the bull nose and the flat cutter. The bull nose puts this small little fillet in the bottom corners, and everything else is pretty much the same. So I'm going to cancel that. The ball end is similar, but it's got a full round over at the bottom. So the length in this case is going to be 100. Tool number 102, diameter 22 this time, and press redraw. You don't get an option for the radius because it just puts a full round radius over the bottom. Depth of cut can be, say, 30. That would mean that only the bottom 30 mil will do cutting. The maximum depth might be 5. That means that it's not going to allow this to go down any deeper than 5, but typically I just leave those blank. And again, I'm not going to worry about the feeds and speeds. We'll get to that in a second. Now we'll talk more about the drills when we're actually doing our class on drilling. The taps we're not going to get into because that's more for metalworking, and the saw blades is more for something like a beam saw. It's not really relevant to our use of Alphacam as a CNC router piece of software. What I do want to spend the rest of our time on is this user defined button. So if I press user defined, you see it says define tool, pick geometry defining cross section, and I don't have it because if I tap escape, in order to make a very specific, unique user-defined tool, I need to first draw the geometry, the cross-section of the tool, then activate this Define Tool tab, then select user-defined, and then pick the cross-section. So I'm going to tap escape a couple of times. I'm going to move back to View XY, and I'm going to do a very simplistic version of that. So let's go to Geometry and Align, and I'm going to draw one over here. So I'm going to start maybe, let's do it precisely. I'm going to start at the point 300 tab 100, enter, and I'm going to make that go up maybe 100. So let's go 300 tab 200, enter. So there's a 100 mil line. And if I want to move that over, then I'm going to go, let's say 310 tab 200, enter, and that point then should be maybe 310 tab 100, enter. So you can draw this that way if you like, or what I'd typically do is I'd use a lot of construction lines first of all to lay it out. So let's say I'm going to start there. I'm going to draw a line across maybe say 400 tab 100, and I can use offsets. Now I'm just making this up as we go. We'll do a more precise version in a second. So I can offset this down, let's say 10 mil, offset down 10 mil, another 10 mil, and I can offset this line over 10 mil. I can extend that line like that, and so on. So in any case, what you have to do is use geometry, not construction. Let's turn off construction. Use geometry to make a shape of a tool that suits you. So let's go to the corner there maybe. The reason I can't pick up that point there, by the way, I'm trying to snap on there, is because that's an intersection. So I need to get down here and press intersection and click the two lines, and now it picks up the intersection. So as silly looking as that is, I'm going to go to Edit, I'm going to go to Trim, All, Finish, and I'm just going to trim away all those little bits and pieces. And anything I can't trim, I'm going to delete, so let's delete that and that. And that construction line there needs to be a solid line, so let's go to Change from Construction to Geometry. And I'll trim away that last little piece there, so Trim, All, Finish, and trim out that little piece. So what I've got there is some funny little V-groove cutter, and I want to mirror it. In fact, you must mirror it. So I want to mirror that. Press Finish. The first point on the mirror line is going to be there. The second point on the mirror line is going to be there. Keep original, yes. I actually then need to delete this middle line, which I can't do because, delete geometry, no, because it's joined on there. I hadn't planned on dealing with that, but let's show you how to deal with it. These are all joined together, that vertical and horizontal and that vertical piece, and I need to get rid of this little piece. So if that's the case, then you simply press Explode, and it explodes all those pieces out. So press Explode, click that, and press Finish. Again, press Explode, click this one to the right, and press Finish. And the same is going to apply here. I can see that bottom slope line. and that vertical line are 1, so I can't delete one without deleting the other. So explode that bit to the left, finish, and explode that bit to the right, and finish. And now I can delete all these little pieces in the center, and that line was actually doubled up, so I need to delete the one underneath it as well. So let's delete those two and press finish, and there we have it. Now the last thing you must do, if you press Ctrl G, you'll see that's all fragmented. So let's go to join, all, finish. And I just want to join all, both. So I'll actually undo that and just join. The toolpaths actually try to automatically apply themselves over here. So I am going to join all, press finish, but I'm just going to join the geometries in this case. That's better. So that was a bit long-winded, but what we have to do is draw the exact cross-section of the tool, draw half it first, and then mirror it, because it has to be a totally enclosed area. You have to have the cap on it, the top on it there. It has to be one single closed loop, so there has to be only a single ghost tool, and it has to be perfectly symmetrical. While I'm at it, I'm going to go to Geometry, Line, and just draw a line across the piece like that. So now that I have the shape of the tool, I can go to Machine, Define Tool, User Defined, and it prompts me to select the cross-section of the tool. So I'm going to select this new cross-section, and it brings in that cross-section there. And you can see it's grayed out the length and diameter because they're already brought in based on the size that I drew it. You can decide whether it's metric, whether it's counterclockwise or clockwise. Depth of cut and maximum cut, all those things can be calculated. We'll show you how to pick up the fixed speeds in a few minutes time, but you can either leave it at calculated or you can specify fixed speeds from experience. For now, I'm going to press OK because I'm happy with that. I'm going to call this Des Test 2. Press save, and it's now saved and created. Just on a side note, if you select any tool, this one for instance, and let's just press OK to save it, this is where the tool needs to be saved, because that tool I'm after drawing, Des Test 2, is now saved in there. If I want you on your computer to be able to use that in future, I'd need to get in there and right click that tool and copy that tool and save it somewhere and then email that to you. You need access to that tool. So the only way to actually get access to the tool is to memorize this tool, this path, where it is. It's on my local disk. It's in a folder called Alphacam. Inside that, there's this Lycom.dat folder. Inside that, there's an rtools.alph folder. That's where you get all the tools. On a side note, if you ever get a version of Alphacam and there's no tooling in it, you can just copy this folder and paste it onto your machine and all the tools will come with it. So getting back on track now, let's try and go to View. Let's go to ISO. I could actually delete this if I want. In fact, I'll do that. So Edit, Delete. I'm going to delete that. That was just as a construction. And now I want to send the cutter along this geometry, that line. So Machine, Select Tool. Des Test 2 is there. Accept that. And I'm going to go to Rough or Finish. Now, because I haven't really paid much attention to this, I'm not sure what -5 is going to look like. Let's run it anyway. Let's see if -5 is enough to actually send that across. So I'll turn off the first operation just to speed it up, which was that first line, and go to the simulation and press play, and let's see how it looks. You can see I haven't really set the speed, so there we go. So it only just went down -5 mil, so it didn't actually get to the biggest part of the cutter. So let's edit that operation. Edit the operation. Let's send it down -10 this time. Press OK. It'll prompt me, warn me that it's about to update and change the operation. That's fine. Press OK. Run the simulation now. And you can see now it's a little bit more like it. I'll do it one more time. Just let's try and get the flat part down into the material. Levels and cuts, let's go down -13. Press OK. Press OK. Run the simulation one more time. There you have it. So that's the cross section of the tool I'm after creating. Now, I didn't spend much time at that because we'll do that in a second, but that's the general procedure that's involved. So getting back on track again, I want to create a tool that will make this edge profile for me. Now, on a side note, there's no point digitally drawing that tool unless you physically can purchase or can have made the exact shape of a tool to do it for you. But let's just assume we get this profile from a catalog where there's an actual cutter available for us to purchase. So zooming in, what we can see is we need this radius 5 mil curve and then just a 1 mil by 1 mil square at either end of it. So here's the block I want to apply that tooling to later. So let's go and look at it straight on. Now somewhere up here in a nice even coordinate, let's go to geometry and align. Let's maybe pick, say 300 tab 300. I'm going to draw a line down, let's say 75. So I'm going to go 300 tab 225, enter. And I'm going to go across, so let's go to 340 tab 225, enter. Now it's not important how you do this, how you draw this. The important thing is that we get the true accurate cross section of the cutter. It doesn't matter if you use construction lines or solid lines like this, but just spend a couple of minutes trying to get it right. So I'm going to go then to edit, offset, and I'm going to offset 1 millimeter, and I'm going to come over to the right a mil and up a mil, and that little square is going to represent the bottom square. I then want to offset 5 mil. So from this line up 5 mil and from that line out 5 mil. And then I'm going to go to geometry and a circle with the center radius. The radius is going to be 5 mil. Press OK. And I want it to actually click onto that intersection. So make sure the snaps is activated and make sure you select intersection. And select that line, and there's the circle. And while I'm at it now, I'll go to edit and offset 1 mil. Going to offset this line over to the right and up like that. And then if you go to trim, I should now be able to pick out the shape of the tool that I'm after. So after all that hard work, we've got the cross section of the cutter we're after. I know it's symmetrical because I mirrored it. So I need to join it now. So join a box around all that and press finish. And there's the cutter we can deal with. So machine, define tool, user defined. Select the profile. There's the cutter for us. We'll worry about speeds and things like that in a second, so just press OK. Going to call this des profile. Press save. Going to close the define tool creation. Going to go back to an isometric view. I don't have a piece of geometry that defines the outline of that rectangle, so I'll draw on one. Geometry, rectangle. It should snap onto the two corners. Now I've got that green geometry. Control G will tell me that the ghost tool is centered. So now if I go to machine, select tool, des profile, that's the cutter I'm after, rough or finish, levels and cuts I know from previously because I drew this to be a cutter that needs to go down -6. I'm going to set the final depth to -6. Press OK, select the corner profile, and now you'll get that exact profile that you're after around the edge like that. So what I typically tend to do, rather than drawing it here, because I find it easier to draw in AutoCAD than I do here in Alphacam, is usually I just draw the profiles in AutoCAD. It takes me a fraction of the time. And then here in Alphacam, you simply just go to Home, Input CAD, either as a DWG or a DXF, and bring the AutoCAD file in here and use it to make your profile. Don't forget, afterwards you can always go to Edit and Delete and get rid of the profile because you don't need it. And there you have the cutters. Now, just so I keep my version of Alphacam neat and tidy, I'm going to go to Machine, Define Tool. Let's just go flat in for a second and just put in a random one for now. 100 and diameter 10. Press redraw, and I'm going to press OK, and I can see in here that's the quickest way to get into this folder. So I want to right click Des 3 and delete that. I want to right click Des Sample Tool and delete that. Des Test 2. I'm deleting all those tools that I've made because I haven't really made those with any precision. I'll leave Des Profile there for a second because I want that, and I'll press cancel. That's the handiest way I think to get in and edit those. Or in an exam situation, if I asked you to also submit the tool that you've created, because I nearly always ask you to generate a new tool to define a very specific cross section, and you must also submit the tool. So this is how you do it. You right click it here, copy it, and then copy and paste it to your desktop or your USB or somewhere that you can save it. Okay. Now, one last thing. So far I haven't talked about the fixed speeds. And if you have a piece of metal that is 100 mil long and say 12 mil in diameter and press redraw, depending on what you're cutting, there are going to be very particular spindle speeds, fixed feeds and down feeds that you will use. Now, a lot of those will actually come from experience, and as you're operating the machine, you usually have the option of speeding up or slowing down all of those. So when creating a new tool for use in Alphacam, you can see we've already dealt with actually drawing the profile, the shape. So typically you're given the shape of the tool. And so as we've seen already, we draw half the profile, mirror it over to get the fully enclosed watertight shape, and then create a tool. And as you can see on the right of the screen here, then whatever that profile is, that's digitally what Alphacam will have as the cross-section of the cutter. So all the different moldings out there, all the different components, all the different toolings, if you go to the proper manufacturer, you can actually download the tool straight away. You don't actually have to draw it, but more often than not, you will actually have to draw a simple representation of the cross-section and then add it to your library yourself. So while a lot of what we're talking about today, a material file and tooling definition especially, is in a document that's uploaded to the Modules Learn Online page. But if you just go to Google and Google the LEITs or the lights, I'm not sure how to pronounce it, catalog, you'll also find that on the Learn Online page. This is just one company that manufactures and sells tooling. So when you go to their website, you can download their catalogs from various different years. And if you want to just buy something nice and simple like a straight cutter, it gives you all the information as to what material this can cut, the safe operating speeds, and cross-sectional drawings of it so you can draw it and include it in your Alphacam. So for example, let's just pick this one at the bottom. D here is the size of the cutter, so the diameter in this case. So you can buy lots of different versions of this, 4, 5, 6, 7, 8, all those different diameter millimeters. There's a gauge length and a nominal length. The gauge length being how long the actual piece of material is, and the nominal length is the effective length, how much, like on a 60mm piece of metal that goes into the machine, you're not going to have the full 60mm of it able to cut. There might only be 10mm of that tool that's able to cut. So how do you know then what speeds to use? So let's say, for instance, you want to buy this component. It's a 10mm cutter. Its length is 52 with an NL of 20. If I go across to the right, there's the ID number. That's the number you would quote to purchase this component. You can see here there's a graph that shows you what feed speeds and what rotational speeds, and effectively all the machining operation that you, or the information that you need to build into that tool. So if I can see here, the workpiece material is plastic coated chipboard. The speed, the N, the revolutions, is 18,000 RPMs. And this is important because this, by default, is for plastic coated chipboard. But there is a correction factor for VF, the velocity of the feed rate. If you're machining solid wood, you have to run it a little bit slower, 0.8 of the speed recommended by the chart. If you're going to cross the grain, 0.7, and if it's glulam, 0.8. And there's a kind of a Goldilocks zone here. So the meters per minimum, the feed rate, either how fast the material moves over the cutter or how fast the cutter moves over the material, depending on how much you're going to remove in one pass. So these particular tools up here, ideally they can remove 8mm of this material and they can move at 6.5 meters a minute. And anywhere within those, sorry, I'm gone too far there, anywhere within those two zones are safe. So you can see the dark blue color, all of those diameter 7, 8 and 9 cutters, as long as the feed rate and the depth end up within that blue area, you're safe with a recommended speed of 18,000 RPMs. So what I'm trying to get at with all of that, when you buy a tool, you either get the piece of paper or the piece of card in with the tool, or you can access their documentation, go to their website and get all of this information. Or from experience, you can set and tweak and adjust the feed rates depending on whether the cutter is blunt or whether you have a particularly tough batch of material, or depending on how deep you have to go. So there's a bit of experience that comes with it, but there is a lot of information here that you can use. Also with that, you can see a lot of the abbreviations here, such as D and N and NL and the gauge length. All of those are also within that document there to give you a great breakdown of all those acronyms and all those meanings of all those different words. Now what I'd like you to do, just to finish off this, is I'd like you to draw your own tool, which is this tool to the right hand side here, using those dimensions. Either draw it in Alphacam or in AutoCAD and bring it in. In AutoCAD you might find it easier to import it in as a DXF rather than a DWG. So just draw a simple door. The rectangular door itself is 495 by 715. Offset in all the sides and the bottom by 80, and just put a radius 1000 arc up at the top. And what I'd like you to do is just simply process that door with that tool Submit that to me, but also submit the tool. So I should get two files from you. I should get an Alphacam file with the door machined out, and I should also get an Alphacam tool file that you can access in the way we spoke about a minute ago, in that R Tools Alpha folder. So when you have that done, please upload just that. You can just don't bother uploading all the previous work. Just upload that door and that tool to the submission called Lecture 18 Class Exercises. So thanks for your time, and next week we'll continue on with the module where we'll talk about drilling and some of the applications and the efficient ways to drill out and automate the drilling process using Alphacam. Okay, so thanks, and we'll talk to you then.